Hello. This recording is an overview for Module 5. It's basically looking at the different Python libraries that we are going to use for data analysis. In Module 3, I wrote it as Module 4, but it was Module 3 that we looked at some probability distributions. In Module 5, we'll combine these data analysis tools that we are exploring with probability distributions so that we can start implementing or applying some of the Bayesian analysis. The libraries that we will look at are Numpy, Pandas, and then for graphs and plots, matplotlib. I'll introduce this, but more of the focus is on Numpy and Pandas, and I'll just use my white board equivalent here, the notepad, to sort of give an overview of Numpy versus Pandas. So Numpy is essentially, you can have it's an underlying structure is an array, and it was initially used for numerical scientific computing, but now so initially the main focus was dealing with numeric data, and then having a set of math operations on them, so you can store whatever values. So for example, I just put some values here, 2, 3, 6, 8, and then maybe 10. Okay, now as with any array or list, the regular Python list, you're going to have an index. So these are the values, and this is the index, 0, 1, 2, 3, 4, and it's that's with pretty much any programming language, array or list. It is a zero-based index, and you can conduct various math operations on them, like you can find the sum, you can find the mean, and all of these are methods that are applied on the NP object. So you can think of Numpy, it's a library, a package. Usually you bring it in or import Numpy as NP, and then we call these methods from NP. So we look at some examples. So comparing Numpy to the Pandas library, in the Pandas library, the two main structures, data structures, are series and data frame. Okay. And a series, well, I said that a lot of the use for Numpy, as it comes, the name denotes it's something that's numerical or number related, but it now can store almost any data type, character, boolean, and so on. While with the Pandas, the series, the way you can visualize it is a series is again a one-dimensional array. A Numpy, you can make it into multi-dimensions, but with a series you think of a name for this. So for example, we'll be looking at states, and then you have an index. So this is the name of the series. You have index. By default, again, the index would be numerical, but you can change this index to be some name. We'll be looking at it later. So if you had West Virginia, Massachusetts, and so on. So you have a name for your series, index, and these are the values inside of the series. Now, a data frame essentially becomes, so I'll just make a note, one-dimensional for a series. So you can see there are similarities. At some point in the original version of Pandas, Numpy series was based off of the Numpy library, but some of what I've read indicates that they've started to move a little away, but the concepts are still drawn from Numpy, so there is sort of this connection. The series draws on Numpy, data frame draws on series. Okay. So what's the difference with the data frame? Well, the data frame becomes a two-dimensional version. It's like a table. So for example, I could introduce another column and call it capital. So this is the capitals of the states, Charleston, whatever, what's the Richmond is, Massachusetts, not sure, so I'll just put Boston here. So you can see that you'll have, so this is one series with states. This is a second series of capitals. Now, we have now combined them essentially to constitute a data frame. You could have another series and so on. So we'll look at specific examples in a little while. We'll start this off. So I tend to keep going a little long, so let me see how long the recording is. Okay, I'll get you started with a series example and contrast it with the generic or simple list. So let's see, I'll just start this off so that we have a basis here. A new Python library. So this is, I'm going to do this for Numpy array, and I just want to show you the difference between Numpy array versus Python list. Some of the basic differences, what you can do with a Numpy array. Okay, so for example, I'll just create a Python list very quickly. And I'll give some values here. Let's see, 1, 2, 3, 4, 6, 10. 7, in case I'm doing something with even and odd numbers, and we can sort of, now if I try to apply, I'll just run this, so I have my list. Now if I try to do something like Python list.sum, try to run this, this is going to come back with an error saying I just can't, there's no method that I can apply on the entire list. So the only way I can do this sum or total is to do a loop, like go through each list item in the Python list and say total is, take each list item, and then I can say print that total. So this gives me, so I need to go through loops typically with the Python list. So there is, if I want to do any type of aggregation operation, searches and so on. But if I create a Numpy array, for this I'll have to import Numpy as NP. This is the convention. Calling this package a library as NP. Now I'm going to create a Numpy list, a Numpy array. Okay, so I'll just call it Numpy array. And this is going to be the way I am calling the NP, the Numpy package, and there is a constructor. So it's very object oriented, so that's another benefit of using Numpy, and I can construct my, I'll just take the same values as I had in here and put them in this array. Okay. So if I run this now, I should, if I just wanted to check Numpy array, let's run this now. It tells me that I have this array of these numbers, and if I want to apply a math operation such as sum, I just say dot sum, and it gives me that sum. So this is obviously a big advantage, working directly getting the result of various math operations without having to go through loops. Another benefit that you will see with Numpy, which you'll apply with pandas, is when you're doing various Boolean operations. So I'll make a note of this because this is pretty important. It's another concept for why you want to understand Numpy, working with Numpy. So this is Boolean operations, Boolean operations and evaluations. Okay. So let me just go through an example here so that you can see what's happening. Now if I, for example, if I want to get all the values in the list that are greater than, let's say, 3. So if I try to do in the Python list, if I said something like this, greater than 3, and if I try to run this, it's obviously going to come back and say it's not supported. Now on the other hand, with a Numpy list or a Numpy array, if I did something like this, that's what happens. Okay. You can see it comes back wherever the values, I'll just print out Numpy array, and you can sort of compare what happened here. So wherever this evaluated to true, so greater than 3, 4 is true. 6 is true, 7 and 10 are true. Where it's false, it basically creates a Boolean array of values where it is true versus where it is false, and stores it as an array. Now, if you want to only get the values, we will see what we need to do. But you can combine multiple types of operators. So, for example, let's say I want to look at at numbers that are greater than 3 and less than, let's see, greater than 3 and less than or equal to 7. So I could have, when I'm combining multiple operations, I need to use these parentheses, so keep that in mind. And this is important. It is this. You cannot use and. You can, in Java and C# use the double ampersand. It is the single ampersand that you need to use for the AND operator. So NumPy array, if it is less than or equal to 7. So let's say I run this. You can see that whichever values in this array satisfy this condition come up with true. Now, the OR operator is a single. It's this. It's about the backslash. So you might have seen it in Java and C#. It's so you cannot use OR. It is this. I think it's called a pipe. So again, unlike in Java and C# where you put two of them, here it's only one when you're using the OR operator. The other operation is the NOT. Which is the tilde sign. So if I ran this, it will basically find that wherever it's false, it'll become true, and where it's true, it'll change to false. Okay, and now at this point, if I were to run or look inside NumPy array, it's going to continue to have the original values. Obviously, that's not changed. But if I say apply this on NumPy array, okay, and then if I put this within square brackets, I'm basically saying apply this, whatever this operation is, onto this array. So if I did this now, you can see if I come and look at this, basically I am saying give me the values of after applying it on the array. But if I go back and run this, you can see I still have the original array. So the only way this would get changed is if I said something like this. So at this point you can see that the array itself gets changed. So unless I make the assignment, it's not going to get changed. So anyways, this is sort of an overview of the NumPy array. In the introduction, in the documents that I posted for the NumPy library, I've shown you a method of how you can go in and use NumPy. And for your homework assignment, I basically want you to use various NumPy various math operations on a NumPy library. So if I go back to this, so I'll just show you what I have asked for you to do on this. So on the assignment, basically I have one question where I want you to apply the Numpy package, and another question which mainly focuses on pandas, much less on the matplotlib. And the reflection question basically asks, since you've used R for a number of your courses, to see how the Python library and toolkit libraries and the toolkit for data analysis compares with R, again based on your experience and working with this on this assignment. I think that's about it for the Numpy discussion. Again, the documents I posted are more detailed. You can take a look at them. I wanted to just give you this overview of both the module, the libraries, as well as Numpy. The next video I'll get more into pandas.